Hey, everybody.
Hey.
Hello.
There.
We'll give it a minute for other folks to join. Hi, Jim. Hello, hello. Okay, we'll go ahead and get started at 3 after. So a few more seconds. All right, it's 3 after, so why don't we go ahead and get started. First thing on the agenda today is Submariner deployment demo using subctl.
Yeah, so that was from me. So this is a follow-up in some way to some of the conversation we had in the last call. In particular, Tim's comment about doing multi-cluster deployments that involve copy-pasting lots of credentials all over the place. So Submariner, for those that don't know, is a tool that provides connectivity between multiple clusters. And so it's available as an operator on Operator Hub, but the deployment using that is a bit complicated. And so Miguel, who's also on the call, came up with this idea of developing a specific tool, which we called subctl, that takes care of the details of keeping track of various pieces of information. So the idea is that you have kube configs that point to the clusters that you want to connect, and it does the rest for you. And so I'll share my screen just to give a quick demo. There we go. Yeah, so this is the operator on Operator Hub. And as you can see, this is all the information that needs to be provided. It's a bit much to ask new users or even experienced users. And so with subctl, it's a bit simpler. The general idea is that we have these two clusters that we want to connect, west and east. And in Submariner, we use another cluster, or you can do this in one of the connected clusters if you want, that we call the broker. And this is used to store various pieces of information and allow the clusters to discover each other, basically. So the first step is to deploy the broker on cluster 1. And so that's it. That was nice and easy. So that just sets up a number of CRDs on the broker, and it stores some information in a file called brokerinfo.subm. And this is Tim's comment from the last call made me laugh a little. compared to this. So basically, this is all the information that the user would have to provide manually in an opaque file. And if you decode it, it looks like that. So there's a bunch of stuff that we probably shouldn't be really shipping around, but that's the way we thought of doing it for the time being. And then to actually join the cluster, you just give that file to subcuttle again. And in this case, you need to disable NAT as well. And so it asks for some complementary information. So here, oh, sorry, I forgot the kubeconfig. And so it asks what the cluster ID should be. This is a unique name, and we'll probably change that to use the default namespace UID. The next stage is to choose one of the non-master nodes to be the gateway. And off it goes. So while it's doing that on this cluster, yeah, I'll start on the other cluster as well. Sorry about that. Oh, I'll just do it here. So that's basically it. So behind the scenes, subcuttle goes and connects to the various clusters that we're joining, finds out what their network information is. So that's the CIDRs here. And then constructs the CRs that we need to push to Kubernetes so that it will get the operator up and running. And the operator then goes off and does its thing and starts the various components of Submariner and gets them connected. And that's it. And so, it's much, much easier than using the operator directly, even with Operator Hub. And that's it for the demo, unless you want me to actually prove that there's connectivity.
I think proof of connectivity would be very interesting to see.
Yep. So so I'll just set up Nginx cluster and Nginx other. So while deploying, I'll run a quick test just to show that we don't have connectivity. Oh, and we need to wait for NetShoot to deploy.
Sometimes it feels like the text console is a little bit messed up.
What was that, Miguel?
Yeah, that, at least for me, it feels like the video feed is slower than your voice because sometimes on one of the windows I see like the operator being deployed, but for what you were saying, it's like it already had finished and stuff like that. I don't know if it's the same for everyone, but at least it is for me. Yeah, oh, there was an issue.
Yeah, it's timed out waiting for the, that's probably just the subtle gave up before the operator finished. So So we're partly running there, and the submariner operator. Oh, right, submariner operator is up, but the submariner itself isn't. Again. All right, and that's it off to the right. And on this cluster, still setting things up as well. And so maybe while we wait for all the containers to come up, it doesn't usually take this long. Are there any comments about the general approach? Questions?
So does this like method of deploying Submariner actually like pull anything from Operator Hub? Does it, or does it just like directly deploy like the Submariner bits?
Yeah, so it pulls from the same repos that the Operator Hub pulls from. So everything's on Quay currently, but it doesn't pull the operator description from Operator Hub. So that's one of the things that we're working on, is to make Subcuttle use OLM if it finds it in the cluster, and have OLM deploy the operator.
Yeah, but not like making it a dependency, because maybe not everybody wants to have an OLM.
No.
Okay.
Yeah, I wanted to comment, now that we have maybe relevant people on the call, like one of the, like the discovery of the network details, that there I had to write like a set of heuristics for different network plugins, that based on the network plugin that you were using, it will figure out some of the details. But sometimes, for example, if I try to do that on GKE, where the API is provided to you by Google or some other providers that also do the same thing, and you only have the cluster nodes, then some of the details were impossible to discover. And I wonder if at some point we can, like, I don't know, make some sort of standard in Kubernetes where those details will be easy to discover. In the case of OpenShift, for example, we have the clustered network CRD, where we have those details, but I guess it's nothing standard yet. Yeah, I think that your clusters are low on resources.
While this is spinning up, do we
Yeah.
maybe want to like pause this demo? And I see there's another
Yep.
demo on the agenda. Or maybe Josh, I think you're actually next on the agenda to talk about the survey.
Yeah. Can you hear me?
Yes.
Yes.
Okay. Having some sound problems this morning, so okay, let me go ahead and share if that works okay. There we go. Okay. You seeing the survey says slide?
Yep.
Yep.
Okay. Now, let me see if that actually works if I go into presentation mode. Where do I go in presentation mode? Is that working, or are you still seeing the original window?
I'm seeing the original window.
Okay. Typical problem.
Oh, wait. Now I
Oh.
see big window.
Oh, you did? Okay. Well, then let's
For
go
a moment,
that.
and now I see.
Okay, let's try it again. Seeing the
right.
big window?
Yeah.
Okay. Okay. So we did a survey of as many people as we could reach. Over about 69 responding parties so far. The survey is still technically open, although we're not we got basically 2 surges of responses, once when we initially announced the survey, and the second time after KubeCon San Diego, after we had the SIG Multicluster session there. However, in terms of at least capturing the high end of people running a lot of clusters, we seem to have done pretty well. In this pool of respondees, there are over 26,000 clusters under management. Pardon me. Although admittedly, 24,000 of those belong to 2 respondees, which you'll see in a minute. I want to talk a little bit more about who responded before we get into what they said. We had options for organization type, which include end user, provider, host, research, consultant, organizations that do everything. And we've got a fairly decent distribution there, particularly we have almost half of our respondees are end users, which is nice to have, looking at this from the perspective of utility. Most people are using Kubernetes in production. Again, what we would like to see out of who we want to reach. Hold on just a second. Sorry, just really congested this morning. We allowed respondees to respond on their own behalf, which is what most of them did, or to respond on behalf of their customers. And in that case, they could either sort of say, hey, in general, across our customer base, this is what we're seeing, versus, hey, I'm a sales rep and I'm going to fill this out on behalf of my one big customer. Only 2 people did the one customer thing. For SIG involvement, this was a lot more skewed earlier on. After KubeCon, we got a bunch more people who had just heard of the SIG at KubeCon, basically. And so we've got sort of an even split between people who just heard of it and people who are sort of active followers of what we do, with a minority of people who are directly involved in the SIG. By the way, you can interrupt at any point with questions. And after we get through this, if there are additional things that you find might be lurking in the data, I can quickly check. Somebody have a question?
Yeah, Jeremy here. I'm curious about the multiple customer responses. Do we have a sense of like how many customers are represented by each one of those?
We didn't ask.
Okay.
We did not ask how many customers they were responding on behalf of. If I go back and look at what organizations those are, if they said they were allowed to be anonymous, then I can probably guess how many customers we're talking about, or what industry sector they're in, right?
Okay.
But yeah. Okay. Just some brief sort of breakdowns on cluster size, trying to get an idea of not cluster size actually. This should be, whoops. Sorry, I should relabel that. There should be number of clusters. I just realized, not cluster size. I'm going to issue a new set of slides because I saw another mistake earlier on. So, because actually there's another row below this that says vendor, and as in software vendor, and it's getting cut off. There weren't very many of those. There were only 3 of those. Anyway, I divided this by category because I thought it'd be interesting to see. Overall, what we're looking at is end users actually have the largest sort of, we have a definite hockey stick distribution in terms of how many clusters people are using, where most of the people responding are running somewhere in the low double digits of clusters, except that there's a few who are running hundreds or thousands. And like I said, we have 2. We have one end user running 5,000 clusters and one everything, and I can tell you who that is in the everything. That's IBM, who is running 19,000 clusters. And those kind of would distort averages and that sort of things, which you can see by the huge difference between the median and the average. I also actually just ran a 90th percentile across our sort of set. And particularly if we stop paying attention to IBM, then we're looking at we're really looking at 100 or less clusters for 90% of our users. So somewhere between 2 and 100 clusters for 90% of our users. So if we were looking at this from perspective of how many clusters should a solution we're looking at be designed to support, at least this point in time, you know, getting our sort of general audience, we're looking at 100 clusters or less. And then we look at increasingly special cases. So one of the other big questions we ask people is, why are they running multiple clusters? Why not put everything in one big cluster or whatever? Getting the extra results actually allowed us to sort of break this out into groups of answers. The number one answer, it continues to be the number one answer, is 2/3 of all respondees were geo-distributing their clusters. So I think anything that the SIG works on needs to address geo-distribution as a use case, because it's the one use case that everyone has. Then we have another group of use cases that is common to more than half of respondees, but only slightly more than half of respondees. And that's application high availability, hybrid cloud, which we defined as both as running multiple hostings. So it could be either several different cloud providers or a public cloud provider and on-premise, but running in more than one cloud. Per team distribution of clusters. One of the interesting things about per team is we had a lot of write-ins that, from my reading, amounted to per team distribution. So I think I didn't write that option very well for people to understand that it applied to them, because people were saying, you know, that they had a cluster per security context, which from my perspective is kind of per team, or not per production context. Sorry. So like one cluster for, well, several clusters for dev, you know, a couple for staging, one for prod, etc. Configuration.
There's like a
Yeah.
weird gray area between per team and per customer.
Yeah.
That maybe some of those fell into, probably.
Yeah. Yeah, and you notice per customer was slightly less popular than per team. I wouldn't read a whole lot into that, because part of it is that we're looking, you know, at people's comprehension of the question. I'm trying to remember what the configuration option meant here.
Me too.
The actual text of the question. The okay, different top level configurations. Upgrades, lots of people want multiple clusters for upgrades. Then we get into a group of answers that address slightly less than half of our respondees. So that is per customer clusters, scaling, in other words, launching multiple clusters in order to overcome the limitations of how many nodes you could reasonably have in one cluster. Failover between clusters, which I personally expected to be a much more popular use case than it actually was.
There's also a gray area between failover and app HA.
Yeah. Yeah, we try to distinguish between failover an application versus failover the entire cluster. But, you know, you always wonder whether or not you successfully made that case. Because like our language for Oh, that one actually failover is specifically cloud provider failover. So things like entire region, you know, say an Amazon region going offline, etc. And so there's a lot of potential overlap between that and hybrid cloud, if you follow me. That is, you know,
Yeah.
effectively. Anyway.
I think that there are other overlaps as well. Overflow and scaling, for example. So I mean, this is super useful data, but I wouldn't necessarily, you know, exclude everything below the blue,
Right.
because there are quite a few
Yeah.
of the orange and green things where if you combine them together, which arguably one might want to do, they become very major factors.
Yeah. I mean, it still does make the argument, though, that if, you know, no solution that we implement can support all use cases. And so if we were looking at starting a new sub-project, for example, I would want it to address geo-distribution plus, you know, 2 or 3 of the use cases, ideally in blue. You follow me? And if it ends up addressing some of the other use cases as well, then that's great. But I'm always looking to address the majority use case before we go into things that fewer people are doing.
Yeah, for sure. I think it's worth noting that all of this stuff, I think, certainly all of the top half of that slide is definitely what we anticipated, and I don't think there are any surprises there. And most of the thinking that's been going on up to now has aimed to address the vast majority, if not all, of those red, blue, and orange items.
Yeah. Now, I did put in specifically some of the write-ins there because we let people to write in their own reasons. And I always weight those more heavily because it obviously takes more effort to do a write-in. And thus that tends to be pretty significant. And so our 3 areas of write-in, one was regulatory compliance, where we actually had 3 organizations say that regulatory compliance was an important reason for them. You know, where, for example, like one of the ones, I won't say that we got this answer specifically, but one of the ones from my own personal experience is Department of Energy is very fond, the US Department of Energy is very fond of requiring different energy providers be separate hardware. And so if anybody was serving the DOE, they might run into the issue of needing to run separate clusters because of DOE compliance, even though those clusters might only be 6 nodes. Security, and I think to a certain extent, security is a use case really overlaps with per team or per customer. But there were a couple of things that were sort of generic security responses that were write-ins that weren't specifically per team or per customer. So I gave them their own category. And then largely because of Bob Killen forwarding around our survey, we got a number of respondees from research organizations. And those are mostly interesting because their responses are very different from everyone else. For example, I found the research organizations actually were fond of Federation V1 because somehow it worked better for their research use cases. Okay. More comments about the reasons here?
Yeah, I had a quick question. So the one thing that superficially looks slightly surprising is the regulation item being relatively small. I was just curious whether, given the wording of the questions, whether the use case of I need my processing and data housed in the EU versus the US versus wherever, if that is wrapped up in the geo-distribution item.
It very well might be. Like I said, regulation was a write-in. It wasn't a checkbox we provided.
Okay.
Somebody had to write that into the other reasons thing. That's why it's
so if we were to revise this or redo this at some point in the future, we might want to explicitly say geo-distributed, not jurisdictional.
Yeah, and then geo-distributed, and then regulatory compliance is a separate thing. Yes. So yeah, if we run this next year, which I think we probably should, then I think we should take all the write-ins, and we're about to see actually a whole a whole question of write-ins that I think we could actually have as a more categorized answer in the future.
Correct me if I'm wrong though, Josh. I'm pretty sure we did have a standard question relating to jurisdictions and data locality and all that kind of stuff for political reasons.
We didn't. We did not. We missed that one.
That's an oversight then, apologies. That was in the original set of requirements, and I thought we had it in the question.
Yeah. So well, I mean, there were like whatever this is, 14 options. I'm not surprised we missed one. And that's why we supplied the opportunity for people to write stuff in. So now we asked this question of what are your primary blockers to operating in a multi-cluster environment, and this was a free text thing. So I went through the text and tried to pick out thematic reasons that people were supplying in their own free text. Do understand that this is me looking at everybody's, hand type responses and trying to come up with what are the main blockers that they're running into. As opposed to them checking checkboxes. I don't know if that makes it more or less valid. Anyway, part of this is you may be getting a little of my interpretation here. The big ones of things that people complained about were management, which was expressed just as management or day 2 operations or a bunch of other things. So the ability to manage multiple clusters, and also configuration, where people are citing the lack of tools to either configure all of their clusters according to a template or make sure that services on those clusters are all configured according to the same templates. Or the exact opposite we got in configuration things, which is they actually need the different clusters to be configured differently, but they need them to still work. So configuration is a major issue for people. Another big one that came up a lot, this isn't necessarily one I would have thought of, not having managed multiple clusters myself since the Kubernetes 0.7 days, is wanting to have sort of a unified service or utility application substrate. Like people cited things like, hey, if they're using HashiCorp Vault for, secure credentials, et cetera, they want it to work across all of their multiple clusters. The other popular problems, sort of observability, top-level observability of all of their stuff, all of the stuff across all of the clusters, all of the individual clusters information. Upgrades were mentioned as a frequent problem, saying, hey, doing a rolling upgrade across many clusters takes pretty much forever. And then, the other one, sort of load balancing also across the clusters, and people didn't feel was good enough. And then we had an assortment of other reasons, like that current multi-cluster tools couldn't really erase the differences between different clouds in terms of differences between different clouds. In other words, they have one cluster on Amazon and another cluster on DigitalOcean, and they can't deploy applications to both of them, that sort of thing.
I wonder how much of that is like difference between the cluster capabilities and cluster configurations and different auth providers. I know there's a different option for auth, but I could see that being like one class of things, and then another being like availability of cloud provider services. My thing only works with managed SQL in X cloud, but not Y cloud's managed SQL thing.
Yeah. Incidentally, I'm actually currently reviewing talk proposals for Southern California Linux Expo, and we're going to accept a proposal that is on exactly this topic from a large end user who's trying to deal with managing Kubernetes across multiple public clouds and having a bad time of it. It's a common thing. You know, a few people felt like the tools, including specifically kubefed, were not mature enough for them to rely on. Several people complained that it was still too difficult to take a workload that had been deployed in one cluster and to move it to a different cluster.
Quick question about the upgrades item. Do you know whether that was, or to what extent it addressed cluster upgrades as opposed to application upgrades across multiple clusters?
Hold on, let me actually look at.
Just a time check quick. I want to make sure that we have time to come back to the
Okay, yeah, so
demo,
let's
and
actually,
then we got
so
another
let's
one
actually
queued
go
up
through the rest
after.
of this, and then we can talk about this later on, or maybe even on Slack. Okay, now one of the things that we wanted to get out of the survey was to get more of a sense of who's using our primary subprojects and what state of use that is. And so we get a different picture. So this is sort of the picture from cluster registry in terms of where people are in terms of using cluster registry. So 7 respondees were either already using the cluster registry or planning to use it in some definite time in the future. Whereas, you know, where that comes to 75% of respondees were like, oh yeah, this looks interesting, but haven't actually done anything with it. That kind of reinforces my expectation, which is that people have heard of cluster registry, but they're not really using it. And then we have had a bunch of responses, and I would say, in terms of the comments even more reinforced the belief that even some of the people who said they were planning on using it, for example, hadn't actually evaluated it, if you followed me, based on their text responses. So this is a kind of a selection of some of the responses on the right. Generally feeling I get is people like the idea, but not very many people are familiar with the reality at this point. And so, you know, but on the upside, if we wanted to really change the API, people are not wedded to the existing project. kubefed has a much higher rate of usership based on these responses. We have more using and more planning. The text comments that I got from people, both from the people who are using it and the people who are specifically not using it, gave me the impression that a lot more people had actually directly evaluated V2 Federation. One of the big pieces of feedback that we got there is one that you've heard before, which is people had issues with the pull-push decision. They got that comment at least 4 times. So, and then the last thing that we sort of asked about here, in addition to asking for comments, is what tools, what non-SIG-MC tools were people using and why? And for the why, we both supplied a blank space for them to write in their own reasons and like 5 potential reasons that people could check off. So for the other ones, first of all, lots of people mentioned internal tools, and I would be willing to bet even more people were actually using internal tools than mentioned them. Other ones that came up, Captain Commodore, Rancher stuff, something called Fog Atlas, which I'd never heard of before. Same with NRP controller. I don't know what that is. A couple of people mentioned Slate CI. Oh, I should put a 2 by that. Sorry. A couple of people mentioned Slate CI. A couple of people mentioned something called Razi. And surprisingly enough, only one respondee considered Istio to be a multi-cluster tool for them.
So I think we should probably end this part of the meeting here just for time purposes. Thanks a lot for the update, though, Josh.
Okay.
It was really interesting. Before we move on to the final demo, like, are the Submariner folks like, are things ready for you to demonstrate connectivity as we were kind of waiting for?
I wanted to say thanks again, Josh. That was really good. Will those slides be shared with the group?
They already have been shared over the mailing list.
Okay.
I see a couple of corrections that I want to make. So I'm going to make those corrections and reshare. And then if you have specific questions you'd like to answer out of the survey data, go ahead and ask me on Slack. We told respondees that their detailed answers would not be shared in any public space.
That's fine.
Yeah.
Thank you.
Yeah. So I can do that. I can do the 20 questions thing. I can't do a data dump for anybody. Okay.
Josh, can you stop sharing, please?
Yeah.
Yep,
thanks. There we go.
Right. So here's, so no cheating, I promise. All the containers are running as they were at the start of the call. And so here we're going to do a quick connectivity test running curl cluster 2 and connecting to cluster 3, which is running Nginx with a 10-second timer, and it answers straight away. So that shows connectivity between the 2 clusters. And that's it from me.
Yay.
All right. Thanks. So next on the agenda is the endpoint slice demo from Jeremy.
Yeah. Hey. So yeah, last time we met, we talked about how we, with some of the new work coming out in Kubernetes 1.16 and 1.17 with endpoint slice and then service topology, we actually have a lot of the building blocks theoretically to do multi-cluster service deployments. And I mentioned that I would throw together a demo of that working so that we can make it not theoretical and actually a real piece to work with. So I'm gonna share my screen right now. Can everybody see this okay? I hope it's not too small. Let me know.
Yep.
Perfect. Okay, so this is a scripted demo, but it's all real. Hold on, my control key is stuck. All right.
Sorry, Jeremy, just out of for context, which company are you with?
I'm with Google.
Okay, thank you.
Yeah, sorry, I'm with Google. Nice to meet you all. So I'm going to run the demo now, and we'll see it all working. So as a setup, I've got 2 clusters deployed in GCE, not GKE, running Kubernetes 1.17 with service topology and endpoint slices enabled. Both clusters are multi-zonal, so I've got nodes in zone A and zone B. And I've got 2 services that I'm going to be deploying. I've got the demo service, which is basically just a simple HTTP server that returns the name of the pod, the cluster it's running in, and the zone with each request. And I've got a pinger workload that just pings that service every second and logs the response. So I'm going to start by deploying the service to each cluster. And so the service deploys 3 pods each in zone A and B, and then 1 service across all of them in cluster 1 with zonal topology set on the service. And then the same thing in cluster 2 with no zonal topology set, and then a pinger in each zone in each cluster. So it's set to talk to its local service. So I'm just using the it's demo.demos.service.cluster.local here. So this is so it started by printing the logs from the pinger in zone A cluster 1, and you can see that it's spreading traffic between all of the backends in cluster 1 zone A, and now we'll show the same thing from cluster 1 zone B. And that pinger is also just talking to its local zone, but spreading traffic around. Now let's look at cluster 2 zone A. Now we didn't set topology here, so we expect that it'll be talking across both zones, and it is, but still within cluster 2. And then the same thing here in the zone B. It looks the same as zone A for cluster 2. So this is just basically topology basics here. Haven't done anything special yet, but I've got endpoint slices in each cluster, 1 in each, and now I want to copy between the two. So you can see here 1 endpoint slice in each cluster, and now I want to copy them. I want to pull them down and copy them to the other cluster. Basically, what I'm doing here is cleaning up the metadata. The most important thing is I'm leaving out the managed by label. So the endpoint slice controller doesn't try to manage these endpoints. So these are just manually managed endpoints. So I've got 1 endpoint slice I pulled down from each cluster. Now I'm going to apply the cluster 2 endpoint slice to cluster 1 and vice versa. And now we'll see the endpoints. So there I've got now 2 endpoint slices in cluster 1 and 2. And the older one is still managed by the endpoint slice controller, but the new one is a manually managed one. And so now if I look at the logs from the cluster 1 zone A pinger service, I can see that it's actually talking across both clusters, but still in zone A. So it's respecting the topology. And now if we look at zone B, we expect to see the same thing. Yeah, and you can see that it's talking now just in zone B, but across both clusters. And now if for the cluster 2 pingers or services that don't have topology, I expect it to be spread across both zones, both clusters, and it is. And we see the same thing, hopefully, for cluster 2 zone B. So that's the demo, basically just showing that we have the building blocks for actually spreading work across clusters right now. And this just uses a regular service today, but with additional endpoints. And it really highlights the flexibility of endpoint slice and things we can do with it with the mix of the managed and unmanaged slices.
So the pinger is hitting a kube service whose endpoints are coming both from the on cluster endpoints and then from the manually managed, like external ones that you've in the demo created a YAML against the API server.
Exactly.
Is that right?
Exactly. So there's each cluster has just one service, the demo service, and the pinger is just talking to that one service, both pingers, the zone A and zone B. But we're also using the new topology in Kubernetes 1.17 to specify which zone across both clusters.
What you didn't show here, I think that would be maybe interesting for a more lengthy demo, would be to turn down the workload in zone A and watch it flip over to zone B when it can't match zone A.
Yeah.
Yes.
But that's not about multi-cluster, that's about topology and services.
Yeah, I guess that for multi-cluster, I mean, we still need something that it's going to maintain those endpoint slices dynamically.
Right.
Right. So that brings up some interesting things. So I guess to start, yeah, like we would need some kind of controller to actually do this copying. Like a bash script it's not a scalable solution. But also, like what I've just showed here, we're reusing the original service with cluster.local, which doesn't really seem to make the most sense just as a name, cluster.local. It seems like it's a little confusing when it now doesn't mean cluster.local or local cluster, right? And then there's also this idea that, I've got the demo in both clusters. So this also is kind of making the assumption that a service with a given name in a given namespace is the same service across clusters. And that seems like something that we'd probably want to put some thought in and maybe look at kind of standardizing it as best practice before something like this would make a lot of sense. Otherwise, you'd have to do all kinds of translation.
Yeah.
So
it's a big assumption.
Right.
Yeah, we've talked about it before in various contexts, and I think that's what KubeFed also does, right? Somebody who knows KubeFed real well?
Sorry, does what?
Assumes that namespaces with the same name mean the same thing.
So it's sort of the KubeFed v2 behavior is, I mean, I think that what you said, Tim, describes it, but it's not an assumption based on the name. It's a, like, I think what you're referring to is the DNS names, and those come from the fact that, like, you're spreading in KubeFed one resource basically across multiple clusters, so it has the same name, like, a priori.
So in KubeFed, sorry, Hector speaking. KubeFed, one namespace, federated namespace is equivalent to a namespace, so it's the same output.
Okay, so if we're all comfortable with that assumption, like, it might be worthwhile to produce like a position statement, right? Like a semi-formal doc that we check in somewhere that says, we're going to assume this as sort of the underpinning of a bunch of multi-cluster capabilities. And that way, at least if people ask about it, they can say, like, this is one of our, like, fundamental foundational assumptions.
I think that is I think it's a safe assumption to make. Like, it logically makes sense to me. It should definitely be explicit if we're going to use that as like a foundational assumption, that we should write those things down.
Right.
I think that would be a great idea.
What I want to head off is proposals that say, well, in cluster A, I'm going to call my namespace foo, and in cluster B, I'm going to call it bar, but I want them to mean the same thing. I think that the complexity that could bring is just not worth the energy. And so I'd like to just make a statement that we're not doing that.
Mm-hmm.
Makes sense, yes.
Just a comment on that, Tim. So there were two kind of schools of thought. So first question is that, does that apply only to namespaces, or does it also then apply to things inside those namespaces? So if I have two services in a namespace with the same name, are they implicitly the same, or can they actually be different?
Awesome question.
Yeah.
I think we can make the assumption about namespaces. I'm less confident that we can make the same assumption about services, although I think probably, but I don't know that we've done the homework on it yet.
Yeah. So the two approaches taken initially were, so there was just a pragmatic approach to use consistent names across clusters to mean the same thing within the context of federated stuff. And then there was an alternative approach, which I don't think we ever implemented, but which we thought was strictly superior, which was to use labels and have labels as a way of defining sameness across clusters. So if you could pick sort of arbitrary sets of labels, you could label your namespaces or your services or your replica sets or whatever they were, and those labels would identify that this was the same thing and different from this other thing.
That sounds complicated, especially if you get into like n-ary matches, as opposed to one-to-one.
Yeah.
Was it what was the value that would bring over just simple naming?
I think it was basically so that to be more decoupled. I mean, it seemed like a better logical thing than just a name. But I could be, I think one could argue both ways. It seems like for the same reason that we don't, name our pods, we use labels to identify groups of pods.
Well, I mean, pods and services and pods and deployments have an implicit n-ary relationship, whereas I think here we're trying to set up a single one-to-one relationship. It's funny that I'm arguing this because when I first learned Go, I was a big opponent of convention over configuration, but I've really come around. I think this is a case where conventionally the name of being the same thing means the same thing. I think the interesting question is it automatic or is it opt-outable, and on what granularity?
Right.
Is there any way that we can document this and share it for comment on interested parties? Maybe the people who responded to the survey you just presented today. I don't know, maybe they are in a good position to have an opinion on this.
Yeah, I'm trying to ask myself what the best format to record these types of assumptions is. I personally think that like the convention over configuration is going to be very important, especially like at high scale numbers. But I don't know. I wonder, like, Tim, let me pick on you since you suggested it. What do you think the output that would describe these decisions would be? Decisions or assumptions would be called? Is it principles, first principles?
I think it's, well, so first of all, I don't know where it would live. Like, we don't have a website dedicated to SIGs, right? So maybe we want to actually cross that bridge. I'm not sure. But somewhere I would say there's a doc that says sort of the foundational principles for multi-cluster components or features or whatever the right word is. That, you know, we share broadly, like everybody write blog posts about why we think this is okay. And if we all agree on it, then it becomes just a thing that every multi-cluster component or project or sub-project assumes. And then it becomes the vernacular. Whereas today, like, we're having a conversation about it because we've never written it down.
Right.
So I think we probably would do well with a small number of clearly enumerated base principles. Principles is a good word.
So does anybody want to volunteer to maybe create like a Google document as a temporary holding area for principles and take a stab at writing that first one out?
Sure, I'll do that.
Was
I'm
that
happy to
Jeremy?
help.
Jeremy. Sorry. Okay.
Yeah, I'm happy to help a little bit, or at least review.
Okay. Well, Jeremy, let the record show you put your hand up. Maybe I think this will be our last meeting for this year, but in the next meeting, maybe we can take a look at your write-up, or you can just give us a short blurb about what you wrote up,
Okay.
or on the mailing list.
Or we have this mailing list.
Yeah.
Yeah,
I'll
I
definitely
hear
share
that Tim likes email.
Yeah, I'm happy to review that as well.
Yeah,
I had
Thank you.
one very brief comment on Jeremy's demo. If we have, I know we have 1 minute left.
We've got a couple minutes left. Go for it.
So first of all, thanks. Super great demo. Very useful, I think. Just one, I think, fairly major principally kind of thing, which is worth bearing in mind. So implied in this demo is that there is some mechanism for keeping essentially all of the clusters aware of all of the endpoint slices in all of the other clusters.
Yes.
Yeah.
Yes. And
I
that's
also want to comment on that before the
And if you sort of extrapolate, you know, currently you've got 2 zones and 2 clusters or something approximately that. But if you look at the survey results, you know, a more realistic kind of scenario is sort of order of 100 clusters and probably more than, you know, 2 endpoints or whatever it is in each cluster.
Right.
You very quickly get into a situation where, first of all, that propagation across all the clusters is sort of an n squared problem, or n cubed possibly. And secondly, if something goes wrong with that, so, you know, you can imagine you've got this agent that's now reconciling everything, deleting endpoint slices from clusters and replacing them with new ones, etc. If that thing goes wrong, it probably goes wrong across all the clusters and globally brings this whole thing down. So it might be worth thinking about that. You know, an alternative proposal is where the clusters don't know about each other or about each other's, you know, individual nodes and endpoints, and rather use, you know, independent load balancers, for example, to manage the stuff locally rather than globally.
So I agree we need to think about this. So I called out the same scalability issues, but I think there's real value in having the sort of endpoint control plane be local to each cluster. from a failure modes point of view, it means that you only ever have to, like every component, Istio and whatever else we're building, only has to look at its own cluster, right? Like today, you have to configure each Istio pilot to talk to each other cluster, which is a disaster. It's just a mess.
But maybe I misunderstood, Tim. I thought this proposed precisely the opposite, which is that where this thing runs is sort of academic, but each one has to go and pull all of the other clusters to find their endpoint slices and copy them into every cluster. And,
well,
but once it's copied in, you only look at your local cluster to get the list of endpoints.
There's also, I think there's an assumption that like the harvesting of the endpoint data would work a particular way. There's probably other ways where each cluster can like beam up to a hub type thing. These are my endpoints from my cluster, and pull down the endpoints from the other clusters. And you know, if that hub is down, fail over to a second hub or a third hub or whatever.
Yeah, I think that's a great point. I think there's like Jeremy was intentionally vague, I think, with how the endpoints end up in other clusters. You could imagine a fully peer-to-peer thing. You could imagine a centralized one, maybe a master elected across cluster one. Like I can imagine different models for how to get those endpoints in.
And maybe it's a combination, or maybe it's it really depends on the use case. I mean, we might have a few different practices for different scenarios.
Yeah, and also from scalability point of view, I think that something that we will need to look at is limiting how services are exposed to other clusters. Like maybe you only want to expose to other clusters services that you have annotated in a certain way that we can find. Yeah, so we limit the scalability problem.
Yeah, so
yeah, I would expect this to be like something that you did for a relatively small number of services, or small percentage of the services in a cluster.
Yes, so that was, I guess, the question of like, is the sameness an opt-in or opt-out sort of thing, or is it automatic? I think that is a big effect on scalability. You know, this is using service. I'm not sure that using service would be the right approach, but maybe we have maybe what we want is a resource that's like parallel to service, that's like a multi-cluster service or an exported service or something. And on the scalability side, you know, we could leave the door open to things like lazy loading. Like if you know, the first time you do a DNS lookup or a VIP lookup or something, then it would load the endpoints, or like, I think there's lots of opportunities for optimization. But fundamentally, like kubeproxy has a scalability problem, which exists regardless of multi-cluster. This will just make it worse. So we need to address that.
Yeah, and just to be clear, this is not purely a scalability problem. It's also a global outage problem.
Yeah, and I expect, I don't know, we need to find some way to like age out local, like if I have a copy of your endpoints and you go away and stop checking in, I need to know when to stop trusting you.
Yeah, there's definitely a TTL property of endpoints that are distributed that way.
Yeah, and you know, that problem exists with load balancers already as well in the local clusters, and it's kind of like a solved problem, or a lot of people trying to solve it. It seems problematic to perhaps have to resolve it in a different way for the same.
Yeah. So lots of open questions. We're over time. I've got to drop off.
Yeah, same. Well, thank you everybody for coming. And I believe our next meeting would be probably, if we did the 2-week thing, it would be the last week of December, but I don't think that's a good time to meet. So maybe we can meet the second week of January.
All right.
Okay.
All right. Thanks everybody. Have a happy New Year and safe holiday season. Take care.
Thank you.
Thank you.
Bye.
Bye, thanks.